Well, so this was number 12 on the 10B. So we have a group of 100 students from different countries to meet the competition. And each student speaks the same number of languages. And for every pair of students A and B, since A speaks some language that student B does not, and the same way student B speaks some language but student A does not. And what is the smallest number of total number of languages spoken by all these students? Okay, the question is slightly challenging to understand what's going on. The thing is, we have 100 students, and then when you pair any of these 100 students, like everyone, like every individual has like a language like that other students in that pair don't know how to speak. And that's true for every one of those 100 students. But we don't really know how many languages each student like speak, because the question says each student like speaks the same number of languages, right? But we do not know how many, maybe 2, maybe 3, maybe 5. But what if that's, let's say 5, let's say every individual like speaks 5 languages. That means one of these has to be different from the student's B. Okay, so student B shouldn't have all 5 in common. So we should have one of them different. So another way of saying, like when you have like a bunch of groups, like maybe 3 language like groups, like then each person speak like 3 languages. Since one of them is going to be always different from the next person, so they are all unique. They are not identical at all. So meaning of that, the number of like different like arrangement, different way of those like grouping is actually unique. So we could just need to know what is that number to be larger than 100, because we have 100 students, because everyone has something different from the any other student, right? So let's say we have total number of languages, let's say n. Let's say this is our n, and then we do not know how many each like person speaks. So let's call this is, let's say k. So the n choose k is the number of different grouping that we can have. Like, because if that's like 2, that means n choose 2 needs to be larger than 100, because that's going to be number of different language grouping is possible. But if case not 2, maybe 3, n choose 3 should be larger than 100, because we have 100 students, and everyone should have something different, right, from the other one. And we just need to know what is the smallest n possible. So from here, you can just start guessing, because if you choose like k is 2, because we need at least 2 for k, then n choose 2 has to be larger than 100, right? And then that basically equals n times n minus 1 over 2, which is larger than 100. So the n times n minus 1 should be at least 200. Since n is an integer, you can just kind of get some reasonable numbers to guess. If you go with 15, like by 14, so that will be like 14 times 10 is like 140. So half is 70, that's 210. That's larger than that, which means n could be 15. So meaning that this is no good, this is no good. So we already know if you have 15 students, like 15 languages, and then if you make a group of 2, like 2 different pairs, like there is like 210 different ways of doing it. So if you have that many people like ways, which will make more than 100 students. So actually there's going to be 110 divided by 2. I mean, 210 divided by 205. There is 105 different ways of grouping 2 languages. Okay, so that's going to be more than what we have. So which is good, because we have at least 3 choices now. So if n is, let's say, you can go with no choice if you really try. Maybe start with the smallest one and test some values. But if you don't want to do that, if you really want to kind of go with this approach, like let's say, and choose like 3 and see what's available, what is not. So you can just go with that as well. But I think it's not going to be that nicer. So because you're going to have n minus 1, n minus 2, and divide by 3 factorial. And then we want this to be at least 100. So you can start guessing, like since we have choices, you can start 12 and then see if that works. If not, you can try 10 and then 9 and stuff like that. You can try that one. But if you keep doing this, I believe when you try 9 and 4, so again, you don't have to try all these because you can just use the choices. What I mean by that, if you are assuming this might be the case, then you can start with like 9, choose 2, which doesn't work because we already know any number choose 2 doesn't work unless 15. So which means we can choose 9, choose 3, 9, choose 4. That's the second shot. So if you choose 9, choose 3, that doesn't work. So if I do 9, choose 4, so that should be this divided by 4 factorial. So these will cancel. So you got 2. So you got 126, which is larger than 100, which means if you have 9 languages, if you make a group of 4 different pairs, like of those languages, you will make this 126 of these, and then you can take 100 of these to give those individual, and you have still 26 more. So which means 9 is actually the least number of language that's spoken by all these students. I hope that was clear. I'll see you in the next video.